Welcome to the next lecture on the course Introduction to R Software. You may recall that in the earlier lecture we started a discussion on the statistical function and we had talked about how to obtain absolute and relative frequencies, as well as we also learned how to obtain different types of partitions in terms of quantiles of a function. Now after giving you that elementary introduction on the analytical tools, in this lecture I would try to give you an elementary introduction to the graphical tools. Right. As you are aware that there are different types of graphics, for example, some of them you already have done, something like histogram, pie diagram and so on. So these graphics can also be created in R software and we would like to see how this can be done. So let us try to start our discussion. There are various types of plots and graphics which gives us information about the data, the information that is hidden inside the data. Right. For example, if I try to make here one plot like this, these points are indicating some data values. You can see here that they are lying on a straight line. Nobody is telling us, but this information is giving us the same thing. On the other hand, if I have a data which is like something like this, you can see here this is indicating that there is a particular type of function which is hidden inside the data. So this type of information can also be retrieved using the different types of plots. So there are various types of plots. In statistics we use 2-dimensional plot, 3-dimensional plot, scatter diagram, pie diagram, histogram, bar plot, stem leaf plot, box plot, etc. and there is a long list. And one thing you have to keep in mind, that sometimes we feel that a statistical analysis is good only when there are large number of graphs. No. Just use appropriate number of graphs and appropriate graphs. That is the moral of the story. But here we would like to see that what can we do in R. In R, there are various types of graphics that can be created: bar plot, pie chart, box plot, group box plot, scatter plot, co-plots, histogram, normal, quantile plots and everything. There is a long list. But here we are going to learn about some of the things, some elementary graphics rather. So first of all we start with a simple plot which is the bar plot. What is the use of bar plot? We have understood what is the concept of absolute frequency and relative frequency. So this bar plots gives us the same information in the graphic mode and they try to create one bar for one category. Right. So this bar plot helps us in visualizing the relative and absolute frequencies of the data, and this consists of one bar for each category. So if there are two categories, there will be 2 bars. If there are 3 categories, there will be 3 bars and so on. And how these bars have been created? The identification tag is height of the bar. The height of the bar is determined by the absolute frequency or the relative frequency of the respective category. That means if the absolute frequency is higher, the height of the bar will be higher. And similarly, if the relative frequency is higher, then the height of the bar will also be higher. This is how we try to interpret it. And this relative frequency or the absolute frequency, that is denoted on the y axis, and these bars are constructed on the x axis. The syntax for creating bar plot in R is BARPLOT, that is simply bar plot, and inside the arguments first option is to write the data vector, and there are some other options also, but here we would like to restrict our discussion to an elementary level. So I am not going to discuss about other options, but you can simply use help, something like help inside double quotes write bar plot, and this will take you to the internet site, and then you can get all the information about bar plot. In order to create a bar plot, we use the function bar plot, and inside the arguments we use the function table x, and this will give us a bar plot which is based on the absolute frequency. And in case if I want to create a bar plot with respect to the relative frequency, then inside the argument I have to give the option for relative frequency, that is table of x divided by length of x, that we did in the last lecture. So now I try to take some example. Okay, you can see here I have given a screenshot. Now in order to show you that how to obtain the help on the bar plot, let me go to the R console, and here I type help, then bar plot, and you can see here this comes out to the R server, and here you can see here all these details are there. So I am not going to discuss these details, but I will request you to go through with details. And here I have given the options which are available on the site. So now we try to take some example, and we try to create the bar plots. So here you see we have considered the same example that we considered in the last lecture, and I also requested you to keep in mind two examples, the data on pizza delivery and this the data on 10 persons who are categorized into two categories, male and female, and their categories are denoted by 1 and 2, 1 for male and 2 for female, and this data was stored in a variable gender, right. So now I try to create the bar plot, and as usual I simply try to write down bar plot inside the variable gender, and I get here this thing. Do you really want to have this type of plot? We discussed that there are two categories. There are two categories. One is for male and another is for here female. There are 7 male members and there are 3 female members. So ideally there should be only 2 bars. What is really happening over here? So if you try to see here, we have made here one mistake. I have used here the variable directly. I have not using the table function. That is why this problem is coming, and actually it is not a problem. This is trying to give you the bar plot for each of the observation. This is for observation number 1, this is for observation number 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see here you had got here 10 observations, and every observation has value 1 and 2. For example, if you try to concentrate on the first 2 observation, first observation is 1 and second observation is 2, and the same is denoted here. This is here 1, the height is proportional to the value 1, and this height is proportional to the second observation 2, right. So this is a mistake, be careful. Now I obtain the table and then I try to create the bar plot. So if you try to see over here, here I have obtained first the table of this variable gender, and then I am trying to create here a bar plot of this variable table gender, and I get here this type of graphic. So you can see here that here this is denoting the category 1, which is for here male, and this is the category 2 for here females. And you have seen that there are 7 male and 3 female. So this number here is 7, and this number here you can see this is here 3. So their heights are proportional to their absolute frequencies. And similarly, if you want to plot the same bar plot with respect to the relative frequency, you can see here, here we are trying to find out the relative frequency, and I am using here the bar plot function with the relative frequency. So I obtain here this graphic. Now suppose I want to construct this bar plot with respect to the relative frequencies. So what I try to do here, here I am trying to compute the relative frequencies, and they come out to be like this, that we had obtained earlier, 0.7, 0.3, and then I used the bar plot function with the relative frequency. So, this is our here relative frequency, and we get here this type of here graphic. So, you can see here this value here is 0.7, which is this value, and this value here is 0.3, which is here this value, and the height of the first category, this is my category number 1, which is here male, and this is my here category number 2, which is here female. You can see here this is 0.3 and this is 0.7, and in both the graphics this is simply trying to indicate that the height of this bar is more than this bar. So, that is clearly indicating that the number of male persons are higher than the number of female persons in the given data set. So, now let us try to do the same exercise with the R software. So, you can see here I try to copy this here gender, and so this is our data set gender, and as usual I try to make here a mistake by simply writing gender variable with bar plot. You can see here I get this thing, right. So, okay, now I try to go with here, and now here you can see when we are trying to move forward, do not you think that it is more easy to use the R Studio? Possibly you have forgotten that we had discussed about the R Studio software in the initial lectures. So, now we are going to a place where you can see that here I am trying to write down the command, and this graphic is coming over a different window, and then I have to switch over this. But if you are using the R Studio software, then these things are given directly on the same window. We will try to show you later on. So, you can see here once I try to do here bar plot with respect to absolute frequencies, this comes out to be like this, and when I try to create the bar plot with respect to relative frequencies, this comes out to be here like this. You can see here this value here is 0.7 where my cursor is moving now. So, now you know that how to create these things, and the same thing I would now try to create with my another data set direction that we had used in the earlier lecture. This data set was derived from the data set pizza delivery that we discussed in the earlier lecture, and we had extracted information on one variable called as direction. And if you recall that there were 3 direction, east, west and center, which were coded as say 1, 2 and 3, and we had obtained this type of data that is stored in a vector, say here direction. Now, I would like to create this bar plots with this direction vector. So, you can see here when I am using here directly here the direction variable without using the table function, I am getting this type of graphic. You can see here these are actually 100 values. Here 1, second category is here 2, and third category here is 3 for the east, west and central directions. But this is the graph that we do not want. So, we try to do the correction and we obtain the correct graphics. You can see here now I am using here a function. So, the entire syntax become bar plot of table direction, which is then absolute frequencies. So, there are 3 types of categories 1, 2 and 3, and you can see here now it is giving us this category 1, category 2 and category 3. So, that is simply indicating, you can see here it is saying that the category 2 is highest, then there is a small difference with the category 3 and category 1. So, I can order the number of orders for the pizza, they are the highest in the category 2 followed by then category 3 and minimum in category number 1. So, if I try to do the same thing with the relative frequency, I can write down the command for the relative frequency here inside the bar plot arguments, and means I am getting a similar information, but now all these values are in fraction because they are corresponding to the proportion between 0 and 1, right. Okay. So now let us try to do the same thing on the R console also. So first I try to copy here the data. So this is my here data. You can see here, and then I try to make here a bar plot directly with the data. So you can see here that is giving you this type of picture which I had pasted on my slide. There are 100 categories over here, but this is the thing which we don't want. We want to use here the table function. So I try to use here this command, and when I try to plot the bar plot with this command, I get this type of bar plot based on the absolute frequencies. So this is category 1, this is category 2, and this is category 3. So there are 3 categories and 3 bars. And similarly, if you want to have it here with respect to the relative frequency, then I can use the relative frequency inside the arguments of bar plot function, and you can see here we get this thing, this curve over here, and here the values are now here 0.4 instead of 40. Right. So this is how we try to create the bar diagram. Next important diagram is pie diagram. So what is a pie diagram or a pie chart? This is also used to visualize the absolute and relative frequencies, but in this case they are not the bars, but they are the sections of a circle. Right. So a pie chart is essentially a circle which is partitioned into different segments, and every segment represents a particular category. So for example, in case if I have 2 categories, as in the example of male and female, so I will have here 2 partition, 2 segments inside a circle. And similarly, if I have some more data where I have got 5 categories, then there will be 5 partitions, and they are indicated by different colors and different types of values. Okay. So the question is how this size of segment is computed. The size of the segment is computed by this formula, frequency into 360 degree. Right. And the syntax to construct a pie chart is PIE pie, and inside the arguments you can write here the data, and then you can give here different types of options are there to get labels and other things. I would suggest you to use the help with the option here, and then try to look about different options. For example, it is possible to change the color, if it is possible to give different types of labels, all those things are there, but here my objective is to retain the elementary level of this introduction. Okay. So now I try to create some pie diagram using the same data set. So if you remember, we had created a variable gender which has 2 categories, male and female, and there were 7 males and 3 females, and total were 10 in total. Right. And now if I try to create a pie diagram, I simply have to give here pie, and I give here inside the argument gender, and you can see this type of outcome I am going to get. What is this? Do you really want this? There are so many categories. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. But how it is possible? There are only 2 categories in your data, male and female. So because I have used here directly the gender, I have not used here the table gender. That is the common mistake which people make. So but this is not a mistake. R is doing whatever you asked to do it. You gave the data and it divided the data into 10 different categories. So now we try to correct our mistake, and we try to construct the pie diagram using the say absolute frequency, and this can also be done with the relative frequency. That will not make any difference because the angle will remain the same whether it is 0.7 or 7, because angle is computed with respect to the total frequency. Okay, so when I try to do it, I get here this type of data. So you can see here that here is a circle, and this circle is divided into two categories. One category is this and two category is given here in the blue color. And similarly, when I try to use this pi function to create the pie chart for the another data set direction, you can see here there are three categories 1, 2 and 3. So, 1 is given by here white color, 2 by blue color and 3 by another color. And you can see there that these angles here, they are proportional to the frequency. You can see here in the first case this angle is smaller than the second angle, because the number of values in the category 1 is 7 and the number of values in the category 2 is 3. Right. So, this is how we try to create the pie chart, but before that we try to do it over the R console ourselves. Right. So, first I try to use here only the gender and I try to show you what mistake we can make. Okay. You can see here that is giving you 10 categories. Now, I try to correct my mistake and I try to say construct the pie chart with the absolute frequency. So, you can see we are getting here the same thing that we had seen in the slide. And similarly, if I try to use it over another variable here direction, you can see here we get here this type of chart. So, you can see here we can get these pie charts without any problem, and that is not difficult to obtain. Now, we come to our next chart, that is histogram. Now, histogram is another popular graphics, and the histogram is based on the idea where we try to categorize the data into different groups, and for each of the group we plot a bar, and the discrimination between a bar chart and a histogram, that means the bar of a bar chart and the bar of a histogram comes here. In bar chart, the height of the bar is proportional to the absolute frequency, but in a histogram the height of the bar is proportional to the area of the bar. That is what you have to keep in mind, and area of the bar is here height into width. Usually we have seen the histogram where the width of the bar is kept the same, and that is why we only try to look on the height of the bars, but that is not actually the correct reason. This widths can also be different. So, in case if the width increases, then the height of the bar will also change, that will actually decrease. So, that is the point which you have to keep in mind, that the area of the bar is the parameter which determines the bar of a histogram. And then there is no condition also that the width of the bar has to be same, they can be different also depending on the situation. In order to create a histogram in say R, we have a command hist, and inside the argument we try to give here the data, and this function will create a histogram using the absolute frequencies. And suppose you want to create the histogram with respect to the relative frequencies, then you have to write like this: command hist, inside the argument write the data, and you have to write down here frequency is equal to false. This here f is the logical value which is say here false. So, obviously in the first option where I am not writing anything, actually I am essentially writing frequency is equal to true, that is the default value, right. And if you want to have more details on the hist option, please try to look into the help menu. That is not difficult for you now to see, right. Now, I try to consider my earlier data set and I try to construct histogram over them. So, first of all I try to take the same data on gender, which has two categories, male and female. There were several males and 3 females, and when I try to write down hist gender, you can see here I get this type of graphics, and now you see how to interpret it. You can see here we had given the values for male as 1 and for female as 2. So, that is why it is trying to divide the value between 1 and 2 in some equal partition, because the software does not understand the difference between a continuous and a discrete variable, right. So, it is trying to say here, well, this is my here category number 1 where there are 7 values, and there is another value here 2 which is here at 3. So, you can see here in this case you need not to compute the absolute frequencies or relative frequencies yourself, but histogram will compute it automatically, right. Similarly, when you try to go for direction data, there were 3 values 1, 2 and 3, there were 3 categories 1, 2 and 3. So, if you try to use this thing, you get here this type of data, and you can see here that this area and this area, that is proportional to the frequency. But since here the width are going to be here same, you can see this is the width, they are going to be here same. So, that is why I can take a conclusion based on the height only, right. But there is an option to change the width also, but I would like you to explore yourself by looking into the various arguments and various options which are given in the histogram. So, now let us try to create this histogram over the R console. So, I will try to make it here histogram of gender and histogram of, say here, so now let us try to create this histogram. You can see here I will use here that same data set hist gender. So, you can see here I am getting this thing, and similarly you can plot the histogram with the data direction, and you can see here that it is coming here like this, right. And here you can see here all this value where I am moving my cursor, this value is here 40. So, that is based on the absolute frequencies, right. If you want to use here the relative frequencies, I have to give here frequency is equal to false, and if you try to look over here, this value is going to be changed. Initially this is 40, and as soon as I enter here, this becomes here, say here something else, because now that is based on the relative frequency. And in the same command, if you try to make it here true, you will again get here the 40 value, you can see here, right. Similarly, if you want to have the histogram with relative frequencies for the data gender, you can just create here gender. You can see here that is the data with relative frequencies. So, now we conclude our lecture here, and we have discussed bar plots, pie chart and histogram, and we have restricted our discussion to an elementary level. Now, there are different types of options. For example, if you want to change the color in a pie chart, or if you want to make a particular type of label, you want to give a name to different categories. Simply in say histogram or in bar plot, you want to write something on the x axis, something on the y axis as per your requirement. These things can also be done. And these are very simple thing. You simply have to go to the entire command of say bar plot, pie or say histogram, and then you have to simply give this option inside the argument, and you have to give the required values over there, and you will get the graphics in the way you want. So, we stop here, and in the next lecture we will come up with some more details on statistical function. Till then, goodbye.